Typing your messages into Streamlit is such a pain. I mean, you have to move your fingers and everything. What if instead we could speak to Azure OpenAI from within our Streamlit app? Welcome to this video on Streamlit. My name is Kevin Fiesel, and I am the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. We have done a pretty good amount with a Streamlit application, and this is going to be the penultimate video in this series, at least until I get a really good idea and create one or more Coda videos, but that's a problem for future me. In the meantime, I want to introduce one more part of the Azure AI experience: speech. Let's briefly go to the classroom and learn a little bit more about the topic before diving into our demo. Microsoft has two models in play for speech analysis. First, there is Azure AI Speech, which was previously known as Azure Cognitive Services Speech. This is a bit older and more established, and it drives the technology behind live captions for Microsoft Teams. The second model is the Whisper model, part of OpenAI. Technically, I should say that Whisper is available both in Azure OpenAI and Azure AI Speech, so things get a bit confusing in this space. Whisper via Azure OpenAI is pretty neat, but it's only available in a small number of regions. Whisper via Azure AI Speech has a similar regional limitation, though interestingly, as of the time of recording, there are only two regions in which you can use both Whisper models: North Central US and West Europe. There are several other regions that support one or the other, but not both. When it comes to deciding between Whisper, whether in Azure OpenAI or via Azure AI Speech, and the classic Azure AI Speech models, Microsoft has a nice table. I'm showing part of the table on screen now. As of this moment, when I'm recording the video, Microsoft recommends using Azure AI Speech for most operations, but you can do a fair amount with Whisper. We'll focus on the Azure AI Speech side of the house today, but maybe in another year or so, parts of this table could change, with Microsoft officially recommending Whisper for certain operations. Now, with that out of the way, I will cover one more small topic, and then we'll jump into the demo. That topic is two modes of speech recognition. The first mode is detection of utterances. An utterance is a short phrase, possibly containing a sentence or two. If you look at the captions on this video, and you should because I hand edit them all, so they should make at least as much sense as the guy talking at you right now. But if you do look at these captions, you will see that they capture a small block of text. That's a bit less than a full utterance, but it should give you the idea. We're collecting a few words and processing those. Then the next caption appears and we take on the next few words. If I pause for a moment during speech, that'll typically start up a new utterance. Utterances are great for command recognition and providing a snappy response to a user request. The alternative is to process an audio stream. With an audio stream, we are still pushing audio content to the speech service, but we're not limiting ourselves to clips and phrases. Audio stream processing is a bit more of a challenge, so we'll see what it takes to implement each of these in Streamlit. Now that we've talked a little bit about the basics of speech processing, let's go to a demo and write some code. Welcome back to Visual Studio Code. I'm here in the requirements.txt file because we are going to need to add a pair of packages for this demo. The first one is Streamlit Extras, a package that offers some extensions to normal Streamlit functionality. The other one covers the Azure AI Services Speech service, which used to be known as Azure Cognitive Speech, hence the name. Let's install these using the pip install command in our virtual environment. This should take just a little bit of time, and our end result is that we will successfully install these packages. Now that we have the right Python packages, let's switch over to the Azure portal. In here, I'm going to search for the term AI Services in the top bar. As of the time of recording, we can see two separate entries named Azure AI Services. I'll select the one whose icon is a cloud, and that will take me to the Azure AI Services page. From here, I'll select View on the Speech Service entry, and that will take me to Speech Services. I'm going to use the CS Speech EUS2 service, but let me quickly show you how to create a new one. You do not need to go through any special approval process to use the Azure AI Services Speech service, so we can simply select the Create button. We'll need to select a resource group and a region. Now, my advice is pick the same region as what you're using for Azure OpenAI. In my case, that would be East US 2. The other important part here is the pricing tier. There are two tiers, a free tier and a standard tier. If we select the View Full Pricing Details link, you'll get to see what's available with the free tier. This includes 5 hours of speech-to-text translation per month, as well as 500,000 characters of text-to-speech and 5 hours of speech translation. Scrolling down a bit to the standard tier, what we're going to use is real-time transcription for speech-to-text, so we would pay about $1 per hour. There are a variety of other services and charges, but what we need to know is that we can get away with using the free tier for this video. The Network tab allows us to limit access to the service based on network, so you could require access only over some specific virtual network and IP address range. The Identity tab allows you to create a system-assigned managed identity or add your own user-assigned managed identities into the mix. Adding a managed identity here gives you a way of granting your speech service access to some other Azure resources. We won't need to do this for our video here, but I do still recommend setting up a managed identity in case you need to work with service permissions later. I'm now going to close out this flyout pane because I won't actually create a new service. I have a perfectly fine service, so I'll select it. On this page, I need two things, my region and an access key. I can see the region quite clearly in the endpoint, East US 2. As for the endpoint key, let's drill into resource management and select keys and endpoint. We have two keys we can use here, so I can copy either one of the two for my purposes. Now let's head back to VS Code and pick up where we left off. Thanks to the magic of preparatory work, I've already added the two secrets to my secrets.toml file in a new section called Speech. That means in the Chat with Data page, I'm going to add two more secrets, one for the speech region and the other containing the speech key. The next thing I want to show is how we can tie in the Azure AI Services Speech service and use it to perform speech to text. This will let us speak our queries, and then we'll submit them to Azure OpenAI and our GPT-4 model deployment. There are actually two ways of doing this. We can capture a single utterance, or we can capture a stream of audio. With utterances, we hear words in clips and phrases. We would create an utterance for a few seconds of audio input, perhaps a sentence or two. The other alternative is to stream our audio, telling the service when we've started and when we've stopped. For the sake of this demo, I am first going to show you how to create an utterance, and then we'll see how we can work with streams. The first thing we'll do is add a reference to the Azure AI Services Speech service to our list of includes. After that, I'll add a button to the sidebar, right below my definition of model type. We'll now need to handle what happens when someone clicks the button, so I'll put this below the definition of my speech region and speech key secrets. We are going to call a function called recognize from microphone, which I'll create momentarily. If we get speech contents, then we'll call handle chat prompt with the text content. Now, I need to create a function that accepts audio and transforms it into text. Let's pop that function in now. This function takes in three parameters: our key, our region, and the language we want to use. I am defaulting to US English, though Azure does support a wide variety of languages for speech-to-text translation. Inside the function, I will load up a speech configuration and set the subscription, the region, and the recognition language. After that, I'll create a new audio configuration using the default microphone on my machine. I'll also instantiate a speech recognizer, preparing to listen for audio in the language of choice. Then it's time to start collecting audio. The speech recognizer has a function called recognize once async, which, when we call the get function on its instantiated object, allows us to capture an utterance. Then I have a few easy checks. If our utterance is something that the service recognized as speech, we are going to return the result's text value. If the service says this was not a match for speech, then we will emit none. Similarly, if we cancel the call, we'll emit none. And if the reason for cancellation was an error, let's write the error details to the console. Note that these print statements will only write to the console and not to our application. So we would probably want to replace this with a proper logging infrastructure. But that's a video for another day, I suppose. And that's all the code that we will need for this simple utterance. So let's try a live demo. I'm going to run Streamlit, and then we'll be able to check this out. The Streamlit application is currently running, and if I navigate to the Chat with Data page, I can see a new speech-to-text button. I'm going to select the radio button for my schema-aware GPT-4 model. After doing that, I'll select the speech-to-text button and ask a question. How many tables are there in the tickets schema of this database? Notice that I didn't need to click any buttons. We submitted the message using only the power of my mind and my vocal cords, but mostly my mind. After a short wait, we can see its response. It looks like I have 9 tables in the tickets schema of the Chicago parking tickets database. Let's check if that is actually correct. There are a couple of ways that I could do this check. I could open up Azure Data Studio or SQL Server Management Studio and query the database itself, but that might not be entirely fair, as the only information available is what was in my Markdown file. For that reason, I'll switch back to VS Code and search in there. And by the way, you can see that my recognition happened here. It recognized how many tables are there in the ticket scheme of this database, which was the question that I asked. Now, I know that the pattern in this Markdown file is that a table starts with 3 hash marks, followed by a bracket, followed by the schema name, dot table name. So if I do a search for 3 hash marks, open bracket, tickets, dot, we can see that I have 12 results, not 9. And by the way, if you count the tables in the ticket schema, you will actually find that there are 12 results. This leads me to one of my taglines about large language models. These things are language models, not knowledge models or truth models. At best, you can treat a large language model like a drunken intern. Sure, it's creative, but you'd better double check all of its statements of fact. Nonetheless, it is still pretty neat that we were able to ask a question using the microphone in Streamlit and have Azure AI Services translate that text to us so that we could submit it to Azure OpenAI. Okay, let's get back to the not-so-live demo. I've shown you one way of capturing an utterance. This works for quick questions like the sort I just asked, but it will not work quite as well if we have a longer-winded question, or even if I just want to pause and collect my thoughts in the process. If I want to do that, I need to take a different approach. I'm going to need to tell Streamlit when recording starts and when it stops. And for that, I need a special kind of button called a stateful button that is available in the Streamlit Extras library. Let's add that to the imports, as well as Streamlit JavaScript evaluation. I'll also add in the time library, as I will need to make use of that in one function call. Next, I'm going to change the definition of the speech-to-text button just a little bit. Streamlit Extras doesn't have the notion of a sidebar baked in, so I'll use the with clause to indicate that I want this button on the left-hand side in the sidebar. I also need to add a key so that Streamlit can keep track of the state of the button in session state, which is what Streamlit Extras is doing for me. The next thing I'll change is the behavior on button click. Stateful buttons have 2 states, on and off. I'll replicate that in my check for whether I've clicked speech to text. We're still going to call recognize from microphone on button click, but it won't return anything. Now, I'll talk about that when we get to the changes I'm making in the function itself. But if the button is in an off state, we'll go to the else branch. In here, we're looking for a variable in session state called transcription results. If we have transcription results, we'll convert it into speech contents. Transcription results will be a list of strings and will contain the text we transcribe from our audio input. Think of each result as a single utterance, and we can have some indefinite number of utterances. Once I'm done with transcription results, I'll delete the variable from session state. That way, if I select one of the other page options, it doesn't keep resubmitting my request over and over. After that, I'll call handle chat prompt. The rest of my main function should remain the same, but I will need to change the recognize from microphone function a bit, as you may expect. I will warn you up front that this is technically overkill for Streamlit, though it is close to the proper way to interact with the Azure AI Services Speech service. The function starts off the same by creating a speech config. The next thing I need to do is create a conversation transcriber. Basically, I'm going to convert the audio input into a stream that we transcribe. We don't know exactly how long this thing should run, so I'll set a variable called done and make it false. I have a function called handle final result that takes an utterance and appends it to the list of all results. Then I print it out to the screen to make sure everything's going fine if I watch the console. The all results variable is just an empty list that will populate with utterances, and I have a function named stopCB to stop continuous transcription on specific event references. After that, I have a few events to which I'm subscribing. The transcribed event will fire off handle final result. The session started and session stopped events will print out a quick message, as will the canceled event. Those final two events, session stopped and canceled, will also call the stopCB function to end transcription. After I register these event callbacks, I'll start transcribing asynchronously. At this point, users will be able to speak into the microphone until they're done. But here's the trick. Because any page action will force a postback, I actually can never call the event to stop a session. This function technically does not return. Instead, I rebuild the page once the user clicks the button a second time. To handle this, I capture the results into session state every second until the user clicks the button to stop recording, and then we'll refresh the page and land in the main function's check for a transcription results variable in session state. This is kind of an ugly way to work around Streamlit's behavior, but it does work, as we'll see in this second demo. All of my changes are in place, and we're running the Streamlit application a second time. Before I go too much further, there are a couple of corrections I need to make. Number one, I am not using the Streamlit JavaScript evaluation library in this code, so I've removed its import statement here. Number two, scrolling down to the bottom, I've actually transposed the loop here for message and session state.messages with the check for if we have the speech to text button selected. This is the correct order, and I had it in the wrong order prior to this demo. With those two changes in place, let's navigate to the Chat with Data page. From there, I will select the Use Schema-Aware GPT-4 model. Then I'll select the Speech to Text button and ask the same question as before. But this time, I am going to pause a few seconds in the middle and then make another utterance, and we should be able to capture both of those here. How many tables are there in the tickets schema of this database? Make sure you include all of the tables in that schema, not just some of them. After clicking the button to stop recording, we'll submit the results to the GPT-4 deployment. And this time, it required not only my mind and my vocal cords, but also my George Jetson button-clicking finger. I've waited for the results to come back, and once again, the answer is not correct. We really should have had 12 tables. Another thing, you may have noticed that I paused for several seconds at the end before clicking the button to stop. The reason for that is I needed enough time for the Cognitive Services or Azure AI Services Speech service to finish processing and then send the results back to us and then wait up to 1 second and put it into session state. So I did need to give it a little bit of time to finish its processing because, again, I'm taking advantage of the oddities of how Streamlit handles postback. And so I needed to wait until I guaranteed I had that information in the session state before continuing on. Nonetheless, the neat part of this was not so much in getting the right answer as it was being able to translate speech to text, even when I input a lengthier delay in the process. That was audio processing in Streamlit. I would like to take a small step back and talk about what we have accomplished during this series. We have built, in a few hundred lines of code, a full-fledged application that includes reading data from a database, showing visuals on the screen, slicing by several relevant features, chat with a GPT-4 model, chat with a GPT-4 model over our database schema, and using Azure AI Speech literally to chat with our GPT-4 model. We are displaying a chat history for users and could safely check this code into source control because we're not exposing any secrets. This is a big part of why I like Streamlit. When you're on that Streamlit happy path, there is a lot you can do in not so many lines of code. In the final video of this series, we are going to talk a bit about running Streamlit in production. We'll have links and show notes in the description below. And until we see each other in the next video, take care.